All right, students, this is Mr. Bornheimer. Let's go ahead and get started with today's lesson. Today we are going to be talking about the area of other figures. And the primary discussion for today is going to be based on this idea of finding the area of a trapezoid. However, we are going to focus on some abnormal shapes as well. All right, let's go ahead and begin. So first and foremost, we're going to focus on this idea of a trapezoid. To review, a trapezoid is a type of quadrilateral. So that's a trapezoid. That's a trapezoid. That's a trapezoid. And then you also have trapezoids that can be on their side. It can also be like that. The main thing about a trapezoid, and this is the main thing to keep in mind, is that trapezoids have one set of parallel sides. Okay, so a trapezoid has one set of parallel sides. That's what makes a trapezoid a trapezoid. It is a type of quadrilateral, so it has four sides, but it has only one set of parallel sides. Okay, as opposed to rectangles and squares and rhombuses and diamonds that all have parallel sides. Maybe not diamonds, but the rest have multiple sets of parallel sides. Trapezoids have one. So in order to kind of continue with this, we need to understand when we're looking at a trapezoid what we're talking about. So trapezoids typically have a height. So I'm going to go ahead and the height is perpendicular to those parallel sides. Okay, so again, if you recall, okay, parallel sides being here and here, okay, that height is perpendicular to those sides. Okay, and then we also have these bases. So we have a base. We have a base here, and we have a base there. So there is our trapezoid. And when we are trying to find the area of a trapezoid, okay, we're going to use these measurements. Now, key thing, first of all, the bases will always be the parallel sides. Okay, that's very, very important. The bases will always be Now you might be thinking, well, what's the big deal about that? Well, if you have a trapezoid that is on its side, okay, and you don't know it's on its side. So let's say that we have one here, like so. Okay, we have this trapezoid here. The parallel sides of this trapezoid are here and here. Okay, those are the parallel sides. And when we think about the base of something, right? When we think about the base of something, we normally think of like, okay, we have a flower pot. And a flower pot sits on its base. So we might be thinking, oh, there's the base. Or we might be saying, hey, can you set the base to that stand down? Okay, well, then you might be thinking, well, hey, there's this stand, and it sits inside this base. Okay, but that is not what we're talking about with a trapezoid. We have to be very careful about that. The base is not always the thing that is down. Okay, that is not the base. The bases are the lengths of those parallel sides. Okay, so we've got to keep that in mind here. And if you have to think about it, you can always rotate that, that trapezoid so that it sits, so that that makes sense to you. Okay, now the area formula for a trapezoid is very simple, okay, but it's a little bit different than any of the formulas that we've seen thus far. All right, to review, okay, so to review, we've looked at the area of a triangle. Okay, so a triangle's area is 1/2 base times height. We've looked at the area of squares, rectangles, parallelograms. The area of those is just base times height. Okay, so these are the area formulas we've looked at thus far. The area formula for a trapezoid is going to involve these bases, and it's going to be equal to 1/2 times the height times the bases, we'll call them base 1 and base 2, added together. That's how you find the area of a trapezoid. So I repeat, you take 1/2 times the height times the sum, or the addition, of the two bases. So let's work through this in a couple of examples. Okay, here we have example number 1. In example number 1, we are going to apply the formula we just learned for finding the area of a trapezoid. So we want to find the area. The area is this space inside the trapezoid. And to do that, we're going to go ahead and use the formula. Area equals 1/2 the height, base 1 plus base 2. So we need to identify these three variables: height, base 1, and base 2. Height is going to be that portion of the trapezoid that is perpendicular to the two parallel sides. I repeat, it's the line that is perpendicular to the two parallel sides. So there is a line right here that is perpendicular. We can see that here with the right angle symbols to the two parallel sides. So the height of this particular trapezoid is going to be 15. I should probably use a pen here. Is going to be 15 centimeters. Now the two parallel sides are our bases. So base 1 and base 2. And I really do need to emphasize it doesn't matter which one is base 1 and base 2, since you're just going to add them together. So we can go ahead and just write them down. Base 1 is going to be 8.5 centimeters. And base 2 is 13.5 centimeters. So for our purposes here, we don't need this measurement, 15.8 centimeters. It is not a useful measurement to us as we're trying to solve this example. I'm going to go ahead now and plug in these values. I have 1/2 the height, which is 15, times the sum of 8.5 and 13.5. I'm going to go ahead and break this down a little bit. So 1/2 times 15. And I'm going to add 8.5 and 13.5. If you add the halves, you get 1. And if you add that to 13, you get 14. And if you add on the 8, you get 22. So you want to break these down in pieces. Okay? Now, I can take half of 22. So I can take half Okay, so the half here of 22, I can take half of 15. It doesn't matter what I take half of, but I can take half of either number. 22 is an easier number to take half of. So I'm going to go ahead and take half of 22, and I'm going to get 11 times 15. And the answer of that multiplication is going to be 165. And then I just want to make sure that I include my units, centimeters. And there it is. We solved the area of that particular example. Moving on to example 2. All right, now in example number 2, we are going to go ahead and use our area equation. And we need to identify which of these variables, so we have 3, we have height, base 1, and base 2, which of these 3 we have here. Now I will tell you one is missing, right? And so if we're looking at this particular trapezoid, we have our 2 parallel sides. You can see one parallel side here, and the other parallel side here. And so those parallel sides represent our bases. So if I were to start to fill this equation in, I could say, hey, area equals 1/2. I don't know the height, but I do know that I have 6 plus 21. Now, if I don't have the height, and the height's not given to me, and we haven't determined how to use any other techniques or tools mathematically to get the height, then I wouldn't be able to proceed. And that's important for you to understand. You need to have all of the pieces of the problem in order to proceed. So it just so happens that I do know the height to be, and the height must be perpendicular to those bases. The height happens to be 6 meters. So we can continue. Area equals 1/2 6. And now plus 6 plus 21, which is 27. So I can continue. I can just work this and simplify this further. Area equals 1/2 of 6 is 3 times 27. And that will give me 81 meters squared. Now, it's very important for you to understand that the units in these problems are really important. Okay, they are very, very important. The meters, the units, are very important. And those units will come back into play at the end. Now, area units are squared. So make sure that you're marking your answers appropriately. Okay, in example number 3, what we are going to attempt to find is we are going to attempt to estimate the area of this lake. Now, this lake is an irregular shape. It has, if you follow the edges of the lake, it's got coves, and nothing about it is very straight, but it has the general shape of a trapezoid. Okay, and because it has the general shape of a trapezoid, we can go ahead and discover some information about this lake. Okay, that's very important for us to understand, that we can use what we know about trapezoids to estimate. So that's going to be the key to, is we are going to estimate the area of the lake. Okay, first things first, we're going to pull out our handy dandy equation. Area equals 1/2 height, base 1 plus base 2. And again, if you could start to work through this, you would recognize that we are missing a value. So we need to identify what our parallel sides are. We have a parallel side here. We have a parallel side here, both of which have values. So again, in this particular scenario, we're missing the height. The height of this particular lake or trapezoid, as it would be, the height is 5 miles. So it's from there to there is going to be 5 miles. So let's plug in our values. What's great about this is that we are actually applying this idea of the area of a trapezoid, but the math really doesn't change at all. I mean, it's absolutely exactly the same. We have a height of 5. We have our first base to be 4 and our second to 6, or 6 and 4. It doesn't really matter because the bases don't have to be specific. And so we're going to go ahead and say 1/2 of 5 times 10 would be 1/2 50. And so we would see here that this would equal 1/2, or excuse me, that if you took half of 50, you would get 25. Now, we're not done. We need to go ahead and include our units. So miles are the units in this particular problem. We see that here and here and here, etc. And then, of course, area always includes miles squared, or units squared. And so we are done now with our problem. And we estimate the area of this lake, the surface area of this lake, to be 25 square miles. And so we can use these area formulas to make estimates of real-life places that need to be measured. And that is very helpful if we have a map that we're working off from. Okay, our last example for this particular lesson is going to be to use what we've applied about area and figure out the area of an unknown or other figure. Okay, so we're going to go ahead and do this right now. First of all, what we need to identify is the shapes involved. So what we do when we have a figure like this, notice that it is an irregular shape. Okay, so it's got this kind of slanted box here, and you've got this trapezoid here. All right, what I'm going to tell you is that you're dealing with, a trapezoid, for one. So you have one trapezoid. And you have one square or rectangle. And we're going to talk about that in just a minute. Okay, one square or rectangle. So let's go ahead and proceed. When you're working with an area like this, you need to break it down so that you find the areas of the individual shapes, and then at the end you can add them all together. That's a really important idea. Find the area of the individual shapes and add them, sum them all together. This is the key to solving problems like this. Break it into pieces. So I'm going to go ahead and start with my area of a trapezoid, since that's the one we've been working with. Base 1 plus base 2. I'm going to go ahead and figure out what my values are here. So since this is a right trapezoid, that means it's got right angles. Okay, and this is my trapezoid here. Okay, 5 is my height. So area equals 1/2 5. Now I've also got my base 7 and my base 10. 7 and 10. So I'm going to take 1/2 5 and 17. Now, if I'm going to go ahead and do this, I'm actually going to go ahead and multiply 5 and 17 before I work with the half. So I'm going to take half of whatever 5 and 17 would be. 5 times 17 can be broken into 5 times 10, which is 50, plus 5 times 7, which is 35. When you add that up, it's 85. Now, if I want to find half of 85, well, that's like saying the same thing as half of 84 and then half of 1. So if I want to work with this, okay, if I'm trying to do this using mental math, I could say half of 84 is 42. Half of 1 is 0.5. And so my answer would be 42.5 units squared. That would be the area of my trapezoid. It's very important. So I'm actually going to put that into my trapezoid. 42.5 units squared. I still need to find the area of this second shape. Now, it could be a square or it could be a rectangle. Here's the thing. If it's a rectangle, that means not all the sides are the same. And if that was the case, I would know this side and this side would be 6 and 6. But if it was a rectangle, I wouldn't know those other sides, and therefore I would not be able to continue. If it's a square, on the other hand, and all the sides are the same, and I'm going to actually say that it is a square, then we can use what we know about square, and that is that all the sides are the same length. And so we can find the area of a square given that we only knew this length of the side of this trapezoid. So let's go ahead and apply what we know about the area of a square. The area of a square is base times height. And since squares have the same base and the same height, it's going to be 6 times 6, which is 36 units squared. Okay, the final piece of this puzzle is adding everything up. So I'm going to go ahead and take 42.5 units squared and 36 units squared, and I'm going to add them. I get 0.5, 8, and 7 units squared. So the area of this other figure is 78.5 units squared.